All right, we're on the air. So lay it on me. What are your questions after a lot of chin rubbing over the weekend, pondering C++? Yeah, I need to see calluses on those chins by week 15. Anything? Oh, there's got to be one.
You have one in the ask hot thing.
Yeah, that's an old one.
No,
No, it'll get answered. I think actually that gets talked about formally soon. I'd talk about it today, but I got an assignment that I moved to today. Let me see. Let me look at this. I'm a little bit behind on. I've been trying to stay a week ahead on this what's due when, and I'm a little bit behind on doing that. Yeah, references. It looks like a lab next week is on references, which means that. Oh man, what else do we got going though? I'll probably answer that question on Wednesday. I think Wednesday's the day to answer this one. This actually reminds me of the guy who played Frodo in the Lord of the Rings. Elijah Wood. Yeah. I saw him on a talk show, and he said that. I don't remember the context, but his friend said something about Napoleon, and Elijah Wood pondered it a minute and said, "What's Napoleon's first name?" Right? Napoleon Bonaparte. All right. That's right. Yeah. Of course, I should have thought. All right, can I go in more depth on how clean works in a makefile? Yeah. So, I won't go into great detail about the makefile itself, since that was like a video tips, wasn't it? I hope. It was talked about somewhere, wasn't it? Okay. So that like that. Come on. All right. So if I have an application that consists of two source files, if I built my makefile correctly, this is what my directory is going to look like. You will, in general, have one .o, or I just call it an object file, for each source file. And then you'd have an executable. And I guess the question is, why would you want to clean things up? And I think the answer to that is the idea of distributing your work. For instance, obviously in class you'd want to turn in your application, you'd turn in your makefile, and you want to turn in your source files, and you want to turn in your header file or files. But you don't want to turn in the stuff that is created from those things. In this case, 1.0, 2.0, and a.out, quite simply, aren't needed in order for me to receive your running application. And this isn't just true of this class. Open source software is a huge thing. Open source software being precisely applications whose source code is available to you. And you can go out on the web right now and thousands and thousands, virtually countless, number of applications are now available, or libraries or utilities, for which you can just grab the source code and then you can build the application yourself. And what you need to do that, obviously, is the source code, and you don't need all this object code. Now, would it be bad to provide the object code? There are two reasons not to do it. One is that, I mean, these are pretty small. You can see that 1.cpp is 69 bytes, 2.cpp is 70 bytes, but the object files are an order of magnitude greater. Now these are small, but I mean the general rule goes, the more complex your source files, the much larger your object files end up being. So it takes up quite a bit of room to actually bundle that, and why would I want to bother bundling that if I give you all the source and you can build it yourself, right? The second reason is that these applications generally are portable, meaning that, I guess a good example between portable is my Macintosh operating system and my Windows operating system and my Linux operating system are three totally different operating systems that are going to produce object files and executables that are unique to that operating system and that processor. So my A.out works fine on my Mac, and it'll work fine on your Mac, but it isn't going to work on your Linux or your Windows. And then the same goes all the way around. However, if I give you the source, regardless of which platform you're on, you can build that application, create an A.out that works for you. All right, so there's a rationale for not sending that stuff off to other people. So what you want to do is, prior to bundling this stuff up to send it to someone else, you want to clean out all the stuff that isn't needed, the object files and the executables. So that is the whole idea behind a rule for make, and a lot of times it'll look something. And there's a good example. That means remove all files that end in a .o and remove A.out. Or if you're executable, called something else, put whatever name is appropriate there. Now I can simply do an clear ls, make clean, ls, and you can see that it cleaned up. Why is it called clean? Just convention, right? You can call it. Oh, actually, before I go into that discussion, another principle is that I may say make clean multiple times, and that is a little bit sore on the eyes. Is that the right phrasing? I don't know. I don't like it. I don't like seeing those error messages, right? It makes sense why the error messages are there, because I removed them once, and if I try removing them again, RM's going to complain. But in principle, there's nothing wrong with me calling make clean over and over and over again, and I should see no error messages reported, just in principle. So there's an option you can actually provide to RM, the -F option, which means fail silently. Now if I say make clean, it'll fail silently. Okay, it's not complaining now. So you often see that rule with the -F. Getting back now to the general makefile, why is it called clean? It's convention. There's nothing about the makefile itself that needs to see the word clean in there, right? So you can put the word primate in here, and you can make primate. Makefile doesn't care. The only reason we don't do that is it confuses people. Second, makefiles are, and I hope the materials I provided emphasize this somewhat, that a makefile is a generic tool. I can put whatever I want here, right? I can put an ls here, and it'll happily do whatever I tell it to do. So that's kind of the idea behind make clean. We call it clean by convention, and it removes the artifacts that are created when you build an application. All right. So let me talk a little bit about vectors. I know that I had a video tips on arrays. And the idea behind vectors is, well, let me step back. So the core language of C++ are building functions and those built-in data types, int, float, double, char. Anything beyond that is not part of the core language. I'm having trouble with terms. Is not intrinsic to the language C++, but is part of the standard. And the best example that we've used repeatedly is that string class. The string class is not built in, and I've talked about this a little bit before, where you can notice with the syntax highlighting, if I say int, float, char, the editor is doing a little bit of syntax coloring, kind of showing me that those are keywords in the language. They're really built into the DNA of C++. When I say string, you'll notice there's no syntax highlighting. And the reason for that is that string is actually not built into the language. It is actually some construct that a programmer wrote at some point. And everyone said, that is a fabulous idea, that thing that you built. Let's make it part of the, quote, standard, such that if you distribute C++, if you want to say that you conform to the standard, you will include this string type. And there are a bunch of other things. CIN and COUT are examples of that. Those are not intrinsic to the DNA of C++. Those are things that software engineers developed at some point, and they were decided they are good and they should be in every C++ standard adhering distribution. And so that's why you always see CIN and COUT with C++. And that is what this is getting at, is that there's a whole suite of things that are considered part of the standard, and normally whenever you use them you have to say std : but that gets a little bit trying to type, and so we do a nice useful shorthand on line 4 by saying, let's take everything that's part of the standard and kind of bring it in. What I would say is bring it into our current namespace so that I can refer to it without having to do the std : All right, with that as preamble, not only is there string and CIN and COUT, but there's this whole suite of data structures and algorithms that over the decades have been standardized. They're not particular to C++, these algorithms. I mean, a good example is sorting, right? There's been a lot of work on sorting algorithms, and as you go into 2.11 and 3.11, you'll spend a lot of time looking at different ways of sorting groups of things. And so the standard has, as part of that, ways of sorting. You give it a list of things and say sort, and it'll sort it for you. The one thing that I wanted to focus on today is a container. Container is a generic term for a bag that holds a bunch of stuff. And the container that I wanted to talk about is vector. And a vector is designed to behave much the way an array behaves. And let me just talk about the way an array behaves. Let me see. Let's call this vectors.cpp. All right. And it's part of the standard library, which means if I didn't have line 4 in here, I'd have to say std : vector to start to create one of these things. But let me table that for just a moment and reprise arrays just a tiny bit so that I can use that to compare with vectors. So I can create an array of floats by saying, in square braces, saying how many of them I want. I want 23 of these things. And then in order to access them, I do that. So the key thing that I'm trying to focus you on is how do you create, the way you create an array is you say how many of them you want, and then in order to access them, you just use the square braces and you provide a number in there. And the big limitation to arrays is that you have to know how many of them you need at the time that you're compiling your program, and you don't always know that. And that's where vectors come in. Vectors are wonderful in that they will magically grow as you shove stuff into them, so that you don't need to know how many things you need when you compile the program. You can be running the program, and at that point figure out how many of the things you need. To give you an idea of what it means to know at the point you compile versus the point where you're running, if I want to create a program with the Three Stooges, I know how many of those that I need when I'm compiling the program. If I want to write a program where I ask for all of the grade point averages of the students in your class, where the user's an instructor, I don't know when I'm writing the program how many students are in a particular instructor's class, so I would ask that instructor when the program's running, how many students are in your class? And they say 86. And then I can go ahead and have this vector grow to a size of 86 while it's running. Okay, so that's kind of the distinction there. The syntax for creating a vector is, I'll leave off the std::, vector. And then there's a bit of funky syntax here. You have to, in the angle braces, say what it's a vector of. So with arrays, I say that I have this kind of standard notation where I have the type followed by the name of the variable. Here, I say that I have a vector of floats, and then I give it a name. So I guess I'll call this whatever, students. So that's an empty vector. There's nothing in it. So we need a mechanism for being able to add things to this vector. And the way you do that is you refer to the variable name and then a period. And the function is called pushback. Now let me pause right here. As you continue in your C++ career, you need to start getting good at using the web as a reference. So if I type C++ vector, the c++.com is, there are a lot of good tutorials out there generally, but c++.com is good as kind of a reference. And I like this page because this shows you all the different things you can do with a vector. So I'd basically say dot, and then I could put any one of these things. But what I just am starting to write is this push back, so I can actually look here. Here's pushback. I can click on that, and then it gives me kind of a generic signature of the function. But if I go down, then it shows me an example of using it. So here in this example, they're creating a vector of integers, calling it my vector, and then they're creating an integer variable, and then they say, please enter some integers, enter 0 to n. And they have a do-while loop here, and they have a cin statement where they're reading into that integer, and then they have this push back, and what they're doing is they're adding that integer to the vector, and it'll keep doing that. So note, this is something where you don't know until you're running how many you need, and it'll keep looping until you type a 0. This is a little bit weird to see. Why does the loop end when the person types 0? Also note that this is a little bit, in my mind, a little bit buggy, because if they type a 0 here, it will push the 0 onto the list, and then the loop will end. But setting that aside, why does the loop end when they type a 0? Say that again? Yeah, 0 does count as an integer. But let me ask a general question. If you're teaching someone about do-while loops, you would say the loop is going to loop until what? Until whatever's in the parentheses there is false. Yes? And in the language, so we have this bool type, and we have words true and false, but we also, numbers can be evaluated, or things in the language can be evaluated as true or false as well. And in the language, 0 is false, and anything else is true. Now, people normally think, well, 0 is false and 1 is true. That is absolutely correct. But not only is 1 true, but anything else you can think of is true. The word Todd in double quotes, that's true. Why? Because it's not 0. Okay? And just to say it, this is true. Because that's not 0. That's a string that contains one character, and it has the 0 glyph as that one character. So that's true, right? However, the unadorned integer number 0 is false. So that's why this loop ends. Then they have a couple other things here. They have this thing, size. You can figure out how large your vector is, how many items are in it. So what I'll do is, I'm not going to do a loop or anything. I'm just going to and then I'll say cout number of items in vector, and I'll print out, I'll say students.size, end line, and run that real quick. Control reaches end of no, this is from my previous thing, main. And I guess I'll say return 0. Yeah, let me clear the screen. There you go. Exciting, huh? All right. Now, I mentioned that one of the goals of a vector is to strive to behave kind of like an array behaves. And you look at what I've done so far and you'll go, what the hell, there's nothing in there at all that looks anything like that float stuff you did at top. Well, what I was referring to is specifically this way of accessing an element. So if we want to look at the items, I can say for int I equals 0, I is less than students dot size plus I, and I can say cout student I equals, I'll put it on, what does it equal? Student, I don't want to go on to a different line. Let me do this. I know that ctod type kind of vomits when I wrap lines, so let me put this on separate lines. So I'll put curly braces around that, and I'll cap that with a semicolon, and I'll do another cout statement here, equals students sub I. And I've got too many of those. There we go, I think that does it. So let me compile that and run it again. How do I find the largest number? Let me change the order just to be exciting. How do I find the largest number in there? What do you think? So let me do another loop. We have to look at all of the items to figure out which is the largest, right? So that we know right up front we're going to need a loop. There, we got a loop, finding the largest. Let's create a variable that holds the largest. So what am I dealing with? Floats here. Float largest. And what I'm going to do is I need to initialize it to something. But I can't just throw a number in there because there's no guarantee that, what if 0 is the largest, right? What if all the numbers in there were negative? Then I kind of screwing up my algorithm, so obviously I don't want 0 to be that. The easiest thing for me to do is choose one of the items to be the largest. So I'll just say students, we'll just say the first item is the largest. And now I need to do comparisons. So I go through and loop. I'll be looking at students sub 0 again, but that's all right. Give me an if statement. I want to change the variable largest if I find a new largest number. If, go ahead. Oh, actually, let's see. So here, someone type in an if statement, all secret like. I hear typing. Quick, look around. Who's doing the typing? No, all right. Or you raise your hand. All right, yes.
You can do
Yes.
if
If.
if students square bracket I plus 1 is greater than students at I, then it would set that as the largest variable. Or I plus 1.
All right, I want to make it easier, so let me make it easier. If, let's just go with I. So here, let me do this. Since I started with 0, let me just start counting at 1. Okay, then what do I want to do if that's true?
Set the largest students then.
Yeah, there you go. Now, as far as saying this, I would refer to this as students sub I. So that's the nomenclature I'd use. Oh, semicolon. Now, just to say it, if I did start my loop at 0, it wouldn't make a difference. All it would say, what is my first one? Student sub 0 is 3.14. So all the first iteration would do is say if 3.14 is greater than 3.14. It's not, so it'd go on to the next one, right? So whether you have 0 or whether you're thinking ahead, thinking, oh, I initialize this with the first element, so I'll start at the second element. It doesn't matter. It works. Yes? So the pushback is adding a new item to the vector. And so let's talk about that, why they call it pushback. Because visually, let me see if I go C++ arrays tutorial, so I don't have to break out my drawing stuff. Let me see if I can find a picture. Someone else, but here we go. All right. So if I'm going to provide a graphical representation of an array or a vector, I would do it this way. And the first item would be here. Second item would go here, third item here, fourth, fifth. This is the front of the array or the vector. This is the back of it. So push back means to push onto this thing one on the back end of it. That's why they call it push back. It's basically just adding it to the end is what it's doing. There is a push front. Yes? So you're asking if I say removed items from the front? So everything would shift down. So counting always starts, assuming I have some and I get rid of some of them, counting always starts at 0. Now, it's beyond the scope of this class, but it becomes a very real discussion in 2.11 and 3.11 is, would I want to do that with a vector? And here's the idea. Under the hood, if we were to crack open the hood and look at how it's managing memory, it actually does manage it as a big contiguous list of memory. They aren't willy-nilly around the machine. There's this big chunk of memory and that has all your items. And if you remove the front item, it does have to move 1 to 0, 2 to 1, 3 to 2. And it's computationally, that's very expensive, and particularly if you have millions of items and you get rid of the front run. Then millions of times it has to copy items down. So the question becomes, well, is there a different way of me storing my data, structuring my data so that that isn't expensive? And there is. Just to throw it out there, it's called a linked list. I can do it in one operation, remove the front item, and then say, this is now my front. And it's only like 2 operations instead of millions. It doesn't change the compile time, it changes the run time. So it's very expensive to run the program when you have millions of items and you on a vector and you remove the front item. So what becomes a discussion in 2.11 and 3.11 is you'll look at, I called this a container, you'll look at 3 or 4 different ways of containing data, and you'll say, what situations is one container better than another? And you ask questions like that. Am I going to be removing a lot of items from the front? If so, then don't use a vector. Use one of these other things. Yeah?
Is there a difference between pushback and replaceback?
Yes, and I use in place very seldom, so I actually need to go back and let me see very quickly what it says. Yeah, I would, for our purposes, I would just use pushback. This one is only useful when you're dealing with complex classes that have specific initialization needs. I don't even think they talk about this in 2.11 or 3.11. Yeah, for our needs it isn't. You could use either one, but pushback is going to be the kind of the bread and butter of what we'd want to use. So these questions, I got some questions. Well, can you push things onto the front? Let's see here. It's probably going to be called, yeah, insert. So they don't call it push front here. They call it insert elements. And you could say insert an element at the first position. Pop back would remove the last element. And so you could basically look through these things to see the things that you can do with the vector. All right, so that's my short introduction to vectors. What the hell is L13? A is due before L13 requires completion of L13, does it? All right, hang on. Is L13 this week?
Yeah, it's the second one.
Well, that explains why I had. Let me see what this says. And what's L12? All right, so this is what we'll do. It doesn't matter the order that you do the labs. You could do 13 today and 12 on Wednesday. So that's my way of finessing that part. I originally had this assignment due Tuesday. Let me push back the due date of this assignment a couple days. Let's say that it's due Thursday night. Let me do that right now while I'm talking before I forget. So we'll make this Thursday at 11, and then the submission link goes away Friday at 8 a.m. All right, so that gives you the whole week to do this. And so you'll definitely have that lab. Let's look at the assignment since that came up. Yeah, there it is. All right. Why do I not have? Why am I not required to have curly brackets after that if statement in your for loop? This one here. So if I look at, let's see, BNF, C language. All right. So we don't have to get hung up on this too much. This is like a very dry, generic language description. And note that an if statement is if, and then an expression in parentheses. An expression is nearly anything that you write in the language. A function definition is not an expression. When you create a variable, when I say int x semicolon, that's not an expression. But just about anything else in the language that you've done is an expression. And an expression is basically just thrown out there followed by a semicolon. So you have some expression in here, and then it just says statement. And what is a statement? A statement is an expression followed by a semicolon. That's literally all a statement is. That's not only true of if statements, it's also true of while. While, expression, statement. Any single expression followed by a semicolon. Do, any single statement, while, blah, 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 right? For, and then you can see the for loop just has a statement. So at some point I made the assertion that anywhere in the language that you have a statement, you can have many statements enclosed by curly braces. These three right here. If I want to, I can put those in curly braces. They'll still compile. And so now it raises the question, well, why would you want to do that? In the case of lines 15 through 19, I wouldn't want to do it. This is like this is like being a bragger. Look what I can do, right? Well, why the hell are you doing it? Just to show you what I can do. So I wouldn't do it in that case. That's how I interacted with all my friends until I was 23, by the way. So that means that anywhere you can put a single statement, you could put a bunch of statements in curly braces, and it would be considered a block. And so here, I can either have a single statement, or I can have a whole bunch of statements surrounded by curly braces. So now, this if will either work on a single statement, or it will work on anything in curly braces. And that's the whole idea behind the curly braces. They aren't mandatory to put after an if. It's not mandatory to put it after this for. They are required, however, if I want more than one statement to be acted upon in that loop or in that if statement. So I didn't have it here because it wasn't required. In fact, this for loop here only acts on a single if statement. So I could do that and it'd be just fine. The danger comes when you want to do like this right here. Here I do want to do two separate statements, so I do have to have that in curly braces. And then the common error is not to have the curly braces, in which case the code behaves the way I've written it there, which is the line 23 is looped on, and then line 24 occurs after the loop is over. All right. So we have about 10 minutes left. What I'd like you to do is, let me just walk through this assignment. The attached file, samplestrings.cpp, shows how straightforward it is to build complex strings, build a complex string using the plus equals operator. Let me actually download that. And copy it here, and I'll look at it. All right, we create a string, and now I've got a for loop here that's going to iterate 10 times, and to what is initially an empty string here, I'm going to add an asterisk 10 times over. And then I'm going to add, note there's the plus equals again, I'm going to add to that 10 asterisks a new line, the word fantastic, and another new line. And then I'm going to print 10 more asterisks, or I'm not going to print them, I'm going to add 10 more asterisks to this string result, and then finally I another, after this loop ends, another new line. So what we'll have in the string is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me copy that, I need that. And then on line 12, I do a new line, fantastic, another new line, and then on lines 13 and 14, I loop again and print 10 more asterisks, and then on line 14, I add a new line. So that is what ultimately ends up being inside of result. That's what that's building. So what happens when we print it out on line 16? I'll leave that as a comment. What if I didn't want to what if I, so one thing I note here is the number of asterisks is one more than the word fantastic. So fantastic must only have 9 letters instead of 10. Rather than me hard coding this, oh, let me see, how do I want to do this? Let me create another string. Magic word equals fantastic. There's actually a function that I can call on any string called size. That'll tell me how many characters are in that string. Say that again? So in this case, size would return 9 because there are currently 9 characters inside of magic word, so we would iterate 9 times.
Can you do that to any variable, the dot size?
You cannot do it to any variable. It is like the built-in types. It doesn't make any sense to say dot size to int. But you can do, obviously, with strings. We saw that you could do it with a vector, right, because I did that earlier. And many of the things in the standard library, these containers and so forth, have, if they contain stuff, they will have a size.
Can you do it with, like, can you do it with floats for, like, manipulation?
None of the built-in stuff. And now you can see that it did exactly 9. So a nice little function for finding out how many characters you currently have in the string. And so let's just do this for kicks. Cout result has result dot size characters. I guess I got to quit on this side. G++. How did it come up with 30? I only see 27 there. 9 for fantastic, 9 asterisks, 2 times. So that's 3 times 9 is 27. Why is it saying 30? Say that again? It's a 3 n-line characters. Absolutely. Absolutely. All right, so we'll go ahead and hit the labs and work on this assignment due on Thursday. Yeah?
Could you have it print out the result has, like, that number of characters minus the number of new lines? So, like, print out the actual number instead of 30?
You would, yes, you can't, you would have to, there's a find, if I come here, to, it looks like I closed it, C++ string. So we go to c++.com here. Dot ignore is just for ignoring input, so that would work. There's a, where is it? Here it is. Find. You can find new lines. You'd basically have to find them all and then omit them. So you'd have to write a little loop.